Welcome to Decoding Autism Now, your trusted source for science-backed insights into autism. Our mission is to empower parents, caregivers, and individuals on the spectrum with actionable knowledge, one piece of the puzzle at a time. I'm Dr. Elise Martin. In this 24-part series, we are systematically exploring the science behind the book, Unlocking the Rhythm of Digestion in Autism, by Quay Stoner, available now on Amazon. In today's 5th episode, we delve into a fascinating and critical topic, the opioid peptide theory. We'll uncover how proteins from common foods like wheat and dairy can break down into substances called exorphins, powerful molecules that act like opioids in the brain. These can profoundly hijack behavior, intensify cravings for specific foods, and even dysregulate immune responses, creating a cycle that can be difficult to break. In our journey to understand the rhythms of health in autism, we've explored how something as fundamental as not enough stomach acidity can disrupt the entire digestive cascade. We've seen how pH imbalances prevent digestive enzymes from activating, which in turn blocks the release of key hormones like secretin. This state of incomplete digestion is the crucial first step in our story today. It creates the perfect environment for these opioid-like peptides to form. But what happens when this breakdown produces something so potent? Something that doesn't just cause gut discomfort, but is small enough to slip through a compromised gut lining and cross the highly selective blood-brain barrier? This is where our investigation takes a surprising and vital turn, revealing a direct biochemical pathway that connects diet directly to neurological function and behavior in ways we are only just beginning to fully appreciate. We need to talk about the strange case of gluten and casein. In a healthy digestive system, these proteins are broken down into individual amino acids, the building blocks our body needs. However, when proper enzymatic breakdown fails, particularly the kind triggered by a low pH, these proteins are only partially digested. This results in the creation of what are known as exorphins or opioid-like peptides. The two most commonly discussed exorphins are gliadorphin, which comes from gluten, and casomorphin from casein. These aren't just leftover food bits. They are molecules that are structurally similar to opioids found in narcotic drugs, and they are powerful enough to cross the blood-brain barrier. Once inside the brain, they can bind to opioid receptors, just like a drug would, creating a calming or even narcotic-like effect. Imagine a feedback loop, a reward loop if you will, that is not driven by the body's natural chemistry, but by these food-derived opioids. When these peptides bind to receptors in the brain's reward system, they can create an artificial sense of pleasure or calm. This, in turn, can lead to powerful food cravings, often for the very foods that produce the peptides in the first place: bread, pasta, cheese, and milk. This cycle isn't simply picky eating, it's a form of neurochemical dependency. These opioid peptides don't just hijack the reward system, they also affect behavior and mood. They can reduce a person's sensitivity to pain and alter dopamine transmission, a key neurotransmitter for motivation and attention. Studies have even shown that chronic exposure to these exorphins may delay language development, impair eye contact, and reduce a person's response to social cues. The gut-brain connection is real, and this is a clear example of how it can be hijacked. But the impact doesn't stop there. Remember the CD26 protein we discussed in a previous episode? It's a critical enzyme that helps break down these opioid peptides. However, when gliadorphins and casomorphins are present in high amounts, they can bind to and block CD26. This blockage has a cascade of negative effects. First, it prevents CD26 from doing its job of regulating adenosine levels, a molecule that, when built up, can slow down the entire system. Abnormally higher levels of adenosine slow the methylation cycle, which is essential for detoxification, gene expression, and the creation of neurotransmitters. So you have a double hit: a neurological disruption from the peptides themselves, and a metabolic slowdown from the blocked CD26. Beyond the brain, the effects spill over into the immune system, a critical connection we can't ignore. Opioids are, by their very nature, immunosuppressive, which means they actively dampen the body's natural defenses and weaken its ability to fight off invaders. This happens through a direct biological mechanism. Our frontline immune cells, specifically T cells and macrophages, actually have opioid receptors on their surfaces. When these receptors are activated by casein or gluten-derived peptides, the body's immune surveillance can drop significantly, making it less effective at neutralizing threats. This compromised defense system may help explain the complex immune profile often seen in individuals with autism, where chronic inflammation, autoimmunity, and recurrent infections can coexist. So, how do we know these peptides are a factor? The challenge was detecting them. In the late 1990s, a remarkable international collaboration between researchers Dr. Kalle Reichelt in Norway, Dr. Paul Shattuck in the UK, and Dr. Bob Cade from the University of Florida pioneered urinary peptide testing. This non-invasive method is effective because these small peptides pass through a leaky intestinal wall, enter the bloodstream, and are eventually filtered by the kidneys into the urine. Their groundbreaking results were a watershed moment, showing that a significant number of individuals with autism excrete measurable levels of these opioid-like peptides. This provided a clear biochemical sign of incomplete protein digestion and intestinal hyperpermeability. These urinary tests, still used today alongside advanced stool tests showing gut dysbiosis, paint a comprehensive picture of a severely impaired digestive tract. The good news is that we have several effective strategies that may help break this self-reinforcing cycle. First and foremost, a carefully managed elimination diet can be highly effective. This isn't just about removing foods, it requires a comprehensive approach, often guided by a healthcare professional, to ensure all nutritional needs are met. The most common starting point is a strict gluten-free and casein-free diet, as these proteins are the primary sources of the problematic peptides. Gluten is found in wheat, barley, and rye, while casein is the main protein in dairy products. By completely removing these from the diet, including hidden sources in sauces, dressings, and processed foods, we cut off the supply of these opioid-like substances. This is the most direct way to halt the feedback loop, reduce gut inflammation, and allow the body to begin healing. Additionally, targeted enzyme support can be a powerful tool, acting as a safety net. Supplements containing DPP-4, also known as dipeptidyl peptidase 4, are specifically designed to help degrade any lingering opioid peptides that might be accidentally consumed. Think of them as molecular scissors that help clean up the system. It's also crucial to support the body's natural detoxification pathways, like the methylation cycle, which is fundamental for overall health. This cycle is responsible for hundreds of critical functions, including neurotransmitter production and DNA repair. Providing key nutrients like zinc, B6, folate, and magnesium as cofactors helps this vital process get back into balance, which is essential for neurological health. However, caution is advised. If SAMe is used as a methyl donor, it can create a byproduct called SAH, or S-adenosylhomocysteine. This can be toxic in kids with ASD because the pathway to break it down is often impaired, leading to a buildup of SAH that can further inhibit methylation and increase oxidative stress. We plan to do a dedicated video about that specific pathway and blockage on this channel in the future. It's important to remember that this isn't just a behavioral issue, it's a biochemical one. By addressing the root cause, the failure to properly digest certain proteins, we can begin to untangle the web of neurological, metabolic, and immune dysregulation. The goal is to remove the biochemical noise so the body and brain can find their natural rhythm again. In our next episode, we will explore how the gut produces powerful chemicals called neurotransmitters that influence mood, sleep, anxiety, and social interaction. For a deeper dive into our topics, check out the book, Unlocking the Rhythm of Digestion in Autism, available on Amazon. Thanks for watching. Don't forget to like, share, and subscribe so you don't miss new episodes. It really helps our channel. Sharing is a way you can help others in the community. Please remember to consult a healthcare provider before making changes to your health routine. Final thought for today, sometimes what looks like behavior is really biochemistry asking for a reset.